Soil erosion occurs when natural forces such as wind, ice, or water wear away soil particles. When substantial erosion occurs, large amounts of soil can move and cause serious damage to land and water. Soil erosion reduces the productivity of land, increases sediment in ditches, streams, and lakes, destroys fish and wildlife habitat, and degrades water quality. On a practical level, soil erosion is a waste of money for contractors and homeowners who buy fill, and for towns or neighbors who must clean up the damages. Thousands upon thousands of tons of valuable topsoil are lost each year due to poor planning for erosion control.
In watershed areas, eroding soils can clog streams, cloud lake water, and carry large amounts of nutrients to water bodies, which results in the increase of algae growth in Maine ponds and lakes. Lake waters, which receive heavy amounts of sediment and sediment-carried nutrients, tend to lose clarity, become unattractively slimy in late summer, and ultimately become so oxygen-deprived that fish populations are hurt. The heavy sedimentation of shoreline areas encourages weed growth as well.
Many Maine residents benefit from being near clear, pollution-free water. Developers, contractors, real estate professionals, and homeowners know that the value of shoreland property depends on good water quality. Planning boards, code enforcement officers, and builders must be aware of effective, low-cost erosion control techniques, practices that should be required by municipal officials and used by all people who disturb the earth. When development occurs, the land changes. Wooded land acts as an enormous sponge for nutrient-rich stormwater runoff. When natural forests are replaced by buildings, driveways, and lawns, stormwater is not absorbed. Instead, it rushes into streams and lakes and carries nutrients such as phosphorus from soil particles, lawn fertilizers, gasoline residues on roads, and many other sources. Development creates the need to replace naturally occurring buffer strips with carefully planned measures to control stormwater runoff and soil erosion. Maine towns and cities share responsibility for protecting our land and water from poorly planned development.
It's far easier to prevent erosion problems before they occur than to repair them after they happen. Chemical treatment of lakes and other restoration techniques are expensive and unnecessary in most cases because water quality problems are easily avoided by simple erosion and stormwater controls.
Erosion control theories are easy to understand and apply. There are 5 basic strategies of site planning which will control runoff and reduce erosion. 1. Reduce impervious surfaces on the site as much as possible. 2. Expose the smallest possible area of soil for the shortest possible time. 3. Increase the surface roughness in disturbed areas to retard runoff velocity. 4. Reduce the length of sloped areas to prevent runoff from building up speed. 5. Reduce the degree of slope. Site planning. An essential step in planning erosion control and runoff management is to understand the processes causing soil erosion. If these processes are understood and erosion control is made part of the development plan, future problems of soil loss, drainage, and water pollution can be avoided. There are alternatives for erosion control on most sites. The method selected is generally based on such factors as the timing of construction, extent of grading, and amount of vegetative cover on the land. On most sites, a combination of methods will be needed, such as fitting the development to the topography, limiting the area exposed at any one time, limiting the amount of excavation, and applying appropriate erosion control measures. Detailed information on planning erosion control can be found in the Maine Environmental Quality Handbook. Good site planning is the first step in any development. Detailed information on soils, topography, geology, and hydrology should be obtained for the site. Sensitive natural areas such as floodplains, streams, steep slopes, and poor soils should be identified and protected in the plan. Protect the landscape by fitting buildings and streets to the natural topography. This reduces the need for excessive cuts and fills. Also avoid heavy grading that would alter drainage patterns or result in very steep slopes. Vegetative buffers should be left adjacent to all flowing water to slow runoff, allow for infiltration, and filter sediment. The width of these buffers generally varies from 25 to 250 feet, depending on soil types, density of development, slope, and vulnerability of the water body. In addition to stream buffers, any other desirable vegetation should be identified and protected. Less clearing means less environmental impact from the project. Site planning can be done for each individual lot, but is best done for an entire subdivision. Careful planning can also control the total volume of stormwater runoff generated on a site. Increased volume or velocity of runoff increases erosion potential. When fields or forests are developed, the volume of runoff increases dramatically due to impervious areas such as buildings, driveways, and roads placed over permeable soils. Runoff can be reduced by decreasing impervious areas on the site. This can be done by putting a square footage limit on buildings, driveways, and roads, or by using permeable materials such as gravel instead of pavement. Reducing impervious areas increases on-site storage and infiltration of rainfall. Drainage can also be controlled to diminish its scouring effect. Diversion of upslope runoff around disturbed areas decreases the flow of water through the project area. On-site detention basins can be designed to store and slowly release water. Such basins are designed to reduce peak flows after development to pre-development levels. Careful design of ditches and culvert outlets which carry concentrated flow can also lower the erosion potential on a site. Small runoff channels should be spread out and dispersed into flatter areas. Culvert outlets can be designed to disperse flow with level spreaders or an apron of riprap. The use of trapezoidal, flat-bottomed ditches rather than V-shaped road ditches will also spread out flowing water and reduce erosion potential. Once construction begins, planning can still be used to minimize problems. Earth moving should be scheduled so that only the smallest possible area of land is exposed at any one time. Whenever possible, construction should be planned for the summer to avoid the rainy seasons and allow for revegetation of the site as quickly as possible. These basic planning strategies can eliminate problems up front. However, all sites will still require erosion control measures during construction. The remainder of this video demonstrates how basic erosion control techniques should be used on construction sites. These methods are relatively inexpensive, highly effective, and should be used on all construction sites. Mulch. The cheapest and most effective way to stabilize any site is by generously applying mulch to all disturbed areas. Mulching is used as a temporary control on exposed soils or a permanent control to stabilize a final grade when seeding. Temporary mulching is the most important erosion control method and should be required on all sites. Mulching is the only technique that can be used prior to seeding to stop erosion before it starts. It is effective and easy to apply. Hay is the most common mulch material. Hay can be applied by hand by grabbing an armful and scattering it around. The rate of application should be 4,000 pounds per acre. So count on purchasing about 100 bales for each acre that will be cleared. When the hay is applied, it should be about 4 inches deep, not sparsely applied like this. Mulch should be applied weekly to all bare surfaces. This can be easily remembered with Friday afternoon is mulch time. Every Friday before stopping for the weekend, a group of workers should place hay on any bare earth. After the initial clearing and grading, there will be a need to mulch a large area. However, once an area has been mulched, no further work is needed unless the area is disturbed again or the mulch is blown or washed away. Mulch netting should be required on slopes steeper than 15% and in the bottom of ditches. Staple lightweight paper, jute, wood fiber, or plastic nettings to the soil according to the manufacturer's recommendations. On more level surfaces, anchoring will prevent mulch loss, but is not critical if the site is checked frequently and sparse areas are filled. The simplest anchoring method is to cut the mulch into the soil with a square-edged spade. Make cuts in contour rows spaced about 18 inches apart. A mulch anchoring tool can also be used. This tool is drawn by a tractor and is designed to punch and anchor mulch into the surface 2 inches of soil. These methods are limited to flatter slopes where equipment can operate safely. Mulch can also be anchored with sprayed asphalt emulsion, wood cellulose fiber, and other chemical forms. These techniques are best if money and equipment are available. Hay bale check dams. Hay bale check dams are often used as an inexpensive erosion control measure. Staked hay bales can be placed as a temporary barrier at the toe of a slope or a small drainage way. Hay barriers are useful only when the total area above the barrier is less than 1/2 acre. Barriers should be required at the toe or downslope side of all disturbed areas. Bales should be placed in a row with the ends tightly butting each other along the contour, like this, not this. Each bale should be embedded at least 4 inches and anchored in place by at least 2 stakes. The stakes should be driven at least a foot into the ground. The bales must enclose the disturbed area to trap all silt. Hay bale barriers must be inspected every week and after any major rainstorm for signs of water tunneling or silt plugging. The bales should be replaced if these problems occur. Silt fence. In more sensitive areas, silt fencing must be used in conjunction with hay bales. Silt fence is effective, convenient, and economical. A silt fence barrier is needed, 1, at the base of steep slopes greater than 15%, 2, downslope of high-intensity development with more than half of the original site disturbed, 3, within 250 feet of lakes and streams, 4, anywhere in the watersheds of lakes which are sensitive to algae blooms, such as determined by DEP or used for public water supplies. Silt fence costs about $2 per linear foot and comes in a 3-foot by 100-foot roll. These rolls can be purchased at some hardware or lumber stores. Some soil conservation agencies may sell less than 100-foot lengths for individual homeowners. Installation of a silt fence like EnviroFence is easy. First, a 6-inch by 6-inch trench is excavated along the lower perimeter of the site. The silt fence is unrolled a section at a time, and the posts are positioned against the back or downslope wall of the trench. The posts are driven into the ground until the netting is approximately 2 inches from the trench bottom. The toe-in flap of fabric is laid onto the bottom of the trench. Then the trench is backfilled and tamped to anchor the fence. Silt fences must also be inspected every week and should be repaired if they have been undercut or downed. Large accumulations of silt, more than 6 inches, would require the installation of a second line of fence below the first. Riprap. Riprap is a layer of loose rock placed over an erodible soil surface and usually serves as a permanent erosion control measure. Riprap provides protection in areas where soil conditions, water turbulence and velocity, expected vegetative cover, and groundwater conditions may result in soil erosion. Riprap is used in storm drain outlets, channel banks and bottoms, roadside ditches, drop structures, and shorelines. Stones should be large enough to be stable under design flow conditions with a reasonable safety factor. Sizing information can be found in highway design manuals, local soil conservation offices, or other agencies. Riprap is commonly placed along shorelines to protect against ice and wave action. The Great Ponds Act specifies standards for shoreline riprap, such as using heavy, irregularly shaped rock about 10 to 12 inches in diameter, about the size of a basketball, placed at a 2 horizontal to 1 vertical slope and installed to fit closely together. Properly installed riprap is effective and aesthetically pleasing. Improper riprap design can increase soil erosion and harm aquatic life. Advanced techniques. Advanced techniques and materials are sometimes necessary when a site is particularly vulnerable to excessive erosion or abuts a critical natural area. Sediment traps can be used to intercept sediment-laden runoff. A sediment trap is usually installed in a drainage way, at a storm drain inlet, or at other points of discharge from a disturbed area with total drainage areas of less than 5 acres. There are specific design criteria for the volume, embankments, excavated areas, and the outlets. The traps should be located and designed by an engineer or an erosion control specialist. The plan should adhere to the construction specifications given in the Environmental Quality Handbook of Maine. If any of the design criteria cannot be met, then a sediment basin is needed. Sediment basins are often required on larger projects as a backup or where physical conditions preclude on-site erosion control measures. Basins are a last resort treatment to collect silt before it leaves the site. It is important to distinguish a sediment basin from a stormwater infiltration basin. An infiltration basin is designed to receive stormwater and allow it to seep into the ground for treatment of phosphorus. An infiltration basin must be protected from siltation during construction to prevent soil pores from clogging. Both kinds of basins can be effective, but must be designed by an engineer to ensure a safe structure. These systems are more than a big hole in the ground. Other advanced erosion control materials provide rapid stabilization and are sometimes actually easier and cheaper than hay. Initial costs are higher, but these materials require less maintenance and are durable, often left in place permanently. A product such as hold grow can be used in ditches and on steep slopes in place of hay mulch and meshing if an area is ready to be seeded. Hold grow is an erosion control fabric which covers a seeded and fertilized area, protecting the seed and soil from rainfall, providing a mulch, and repelling excess water. This product is very useful after October 15th, when the growing season ends. In the spring, seed grows under the hold grow, and the paper degrades through contact with the soil and moisture. The knitted yarn serves as a soil binder and protects the root structure. Eventually, the yarn degrades by exposure to sunlight. A product such as Curlex can be used in ditches or on steep slopes when an area cannot be seeded immediately because of the season. Curlex comes in rolls 4 feet wide and can be easily unrolled to cover large areas quickly. Curlex is very effective in areas subject to severe rill erosion, such as large fill areas or newly exposed steep slopes. Another high-tech product providing a cost-effective alternative to riprap and concrete linings for permanent erosion control is Miramat. Miramat is often applied at the outlet of a pipe. This three-dimensional web of bonded vinyl is useful in areas where vegetation can't be established because the rate of flow is too high, more than 10 feet per second, or in areas where severe erosion problems may last longer than a year. Miramat costs about half as much as riprap. Seeding. When a project is completed, or a disturbed area will be left for more than 6 months, the best method for stabilization is revegetation. The goal at the end of a project is for the entire area to be fully stabilized. All areas which have been stripped of vegetative cover during construction, as well as any cut and fill slopes, should be stabilized with mulch and seeding at final grading, unless non-vegetative stabilization techniques are required. Seeding must be carefully timed. Permanent seeding should be made 45 days or more prior to the first killing frost, or around August 15th. Temporary seeding can occur up to October 1st and be reseeded in the spring. In general, a mixture of seed types, such as a conservation mix, is preferable because the variety of seed types can survive under varying conditions. Special seed mixtures can be prepared based on the needs of the site, the desires of the land user, and the characteristics of the various grasses and legumes. Fertilization and liming rates can be determined from a soils test analyzed by the University of Maine Cooperative Extension Service. The standard soils test costs $6 per sample. The Cooperative Extension Service or the Soil Conservation Service can provide information on seed mixtures and rates of application. Finally, in circumstances where rapid cover is needed, hydroseeding is the way to go. Hydroseed is blown on with a machine that combines seed, fertilizer, lime, and mulch all at one time. It is commonly used along roadside ditches during highway construction. Hydroseeding is very effective and covers even steep slopes quickly. Grass can usually be seen emerging within a few days after hydroseeding. Now that you are familiar with several erosion control techniques, it is time to emphasize the need to inspect and maintain the controls until the project area is completely revegetated. A silt fence or hay bale barrier with a gap will not trap sediment during a storm. All controls should be checked routinely every 2 weeks for any problems. Another important time to check the controls is immediately before a major rainstorm to make sure the controls are ready to intercept the runoff. The controls should be rechecked immediately after any storm to repair damage. Be sure that the hay bales and silt fences are not rotted or filled in with silt. The barrier should be a solid, staked line without gaps. Reseed any areas that have washed out. Make sure that mulch covers all bare earth. One final reminder, once a project is complete and new vegetation covers the entire site, remember to remove or break down the erosion controls. The controls are no longer needed, and the site will look finished and better without them. You have just seen a number of techniques which can effectively limit soil erosion during construction. For most projects, these practices do not require special technical knowledge in planning or implementation. For larger projects, there are a number of agencies and printed resources available on planning and implementation of erosion control practices. The costs of controlling erosion are not exorbitant. With a little extra effort in planning, some hay and silt fence, and a little extra time for application and maintenance, Maine's lakes and streams will remain clean for our enjoyment and for the benefit of future generations.